Now, in this class, Ashrima. Okay. Now, given a signal x of t, so it's a periodic signal. I've shown you 3 dots here. Look here. The indication of 3 dots will tell you the signal is periodic. Now, can you tell me what is the period of the signal? Any of you? What is the period of the signal? Any of you? What is the period of the signal? Forgotten? Maybe. Nikita, Shrima, what's the period of the signal? What's the period? How much? Period of the signal is T naught.
0 to T naught.
The T naught is a period. Okay. So how do you define the signal? It is A. Initially the signal is A minus A by T naught into T. So how you got A by T naught? It is nothing but slope. What is the slope? A minus 0 divided by 0 minus T naught. That is A minus A by minus T naught into T. See here, when T is equal to 0, what is the value? When T equal to 0, second component will become 0 and you will get A. That is the actual value of the signal. Look here, at T equal to 0, I have A. Let us see when T is equal to capital T naught, what will happen? Capital T naught will get cancelled here. A minus A will become 0. So at the T naught is equal to at T equal to T naught, you are going to get this one, 0. So you can always obtain by y equal to mx plus c. All of you, many times you have solved this problem. Therefore, I am simply finding what is x of t for one period. That is 0 less than t less than t naught. Now, in any other case, it is 0. Consider for only one period because even though signal is existing for multi-periods. Okay. Now, how do I write this one? This is equal to a minus a by t naught into t. This signal is as it is. Now, I will write this as u of t into u of t minus t naught. What's the meaning? U of t is a signal which starts from 0 to infinity, minus u of t minus t naught is a signal which starts from t naught and proceeds till infinity. So when you subtract these two, u of t from u of t minus t naught, so you are going to get a signal which is 1 between 0 to t naught. Why I should do this one? If I don't do this one, it means that this signal will be valid for indefinite amount of time. That is not the meaning. See here, there is a stopping condition. The signal is existing only between 0 to t naught. That's why I have to multiply this one from 1 between this value. That's why I multiplied it by u of t minus t naught. Are you able to follow this one? Or any doubt you have here? Any doubt here? Why I have written u of t minus t naught? If you have any doubt, you ask me so that I'll be able to explain you. No doubt? Okay. Now, I have to use a differentiation technique to find x of k. It is not straightforward way of finding x of k. I have to use a differentiation technique. So what I will do is, I'll consider y of t is equal to d by dt of x of t. That is equal to, first find the derivative of the signal. So find the derivative. It is in u into v format. Derivative of u into v is u, first function, a minus a by t naught into t, into derivative of this one. What is the derivative of u of t? Derivative of u of t is delta of t. Remember carefully. Derivative of u of t is delta of t. Derivative of u of t minus t naught is delta of t minus t naught. So first function into derivative of this one plus second function u of t minus t naught, u of t minus t naught into derivative of this function is minus a by t naught. Okay. So this is 0. This is minus 1 by t naught into a. Derivative of this is 1. So I obtained the derivative of x of t. Simplify this one. A into delta of t, that is a minus a by t naught into t into delta of t minus this one. A minus a by t naught into t into delta of t minus t naught. So this one into this one minus this one into this one. So you have got this one. And remember, plus into minus will give me minus a by t naught. A by t naught I'll write as it is, u of t minus t naught as it is. Any doubt here? Are you able to follow this one? Any doubt? So I'm simply multiplying the values in the given signal. Once I do this one, I'll just simplify this one. Look here, I'll just simplify what will happen. Look at the function carefully. F of t into delta of t minus t naught is nothing but when you multiply any signal with a shifted impulse function delta of t minus t naught, what you are getting is f of t naught. It will isolate that part of the signal with the value t naught, that is f of t naught into delta of t minus t naught. See here, f of t naught is a number. For example, what is the value of the signal at t equal to 4? And this will tell you at what time this value is existing. Without this one, it will become simply constant and it will not have any meaning. Remember, this is f of t is a continuous time function. When you multiply with an impulse at the time t equal to t naught, you are going to get the value of the function at the time t naught. But this function is going to tell you what time this value is existing. Okay, so now what happens? Y of t is equal to a minus a by t naught into t into delta of t minus this function as it is. I have not changed anyone. But remember, delta of t exists at t equal to 0, this one, and delta of t minus t naught will exist at t equal to t naught, because any other values the delta function will give you simply 0. And the other value a minus a by t naught into u of t minus t naught is as it is. Once you do this one, put t equal to 0 in this equation. When you put t equal to 0 here, it will get you a, and this value will become simply 0 and into delta of t. Now here, when t equal to t naught, this function will completely get cancelled. I have a minus a into delta of t minus t naught, and the second function will remain unchanged. Any doubts? Yeah. Any doubts here? Shiv Shankar or Meghana?
Yes, sir.
Any doubt? Anything not
No,
understood?
understood,
Okay.
sir.
Okay, if you have any doubt, you raise a question in between only. Okay, because I will not know whether you are understanding or not. You raise the question in between only. So when I simplified this one, these terms gets cancelled. Second term gets cancelled here. Okay, and I have a into delta of t minus a by t naught into u of t minus t naught. This function I got. Second function completely gets cancelled. Now this is your y of t. How do I get y of k? Y of k is nothing but 1 by t naught integral for a period of t naught y of t into e power minus jk omega naught t. What is this function? It is a function of Fourier series. Okay, to get the Fourier series coefficients. What is your omega naught? Omega naught is equal to 2 pi by t naught. So I'll substitute this one. What is your y of t? Y of t is complete this function. See here, I taken 1 a into delta of t. This function is as it is into e power minus jk. Omega naught is 2 pi by t naught into k into t. This is the first function. Minus, okay, I taken what? Plus 1 by t naught into minus here. See here, this minus I written here. Minus, sorry, not this one, sorry, this one. Minus here, a by t naught. I taken 1 e power minus jk 2 pi by t naught into t. Okay, and this gives me, once again I'll tell you, yeah, this function u of t minus t naught will generate value of 1 between the limits 0 to t naught. That's why this value is not taken into consideration. Yeah, Pooja, any doubt you have? Okay. So minus a by t naught. Okay. This value becomes 1. That's why not substituted within the limits, and I have e power minus jk 2 pi by t naught. Okay. Once I do this, I have, let us take delta of t will exist only at t equal to 0. Therefore, this integration will get cancelled because delta of t does not exist at any other values other than 0. So what happens? This value will be completely a, okay, by t naught. This t naught is downwards, a is here, e power minus j 2 pi by t naught into kt at t equal to 0 minus a by t naught square. I have integral of this one. What is the integral of e power minus jx? E power minus jx divided by minus j. Okay. So minus j into k 2 pi by t naught minus jk 2 pi by t naught you have here from the limit 0 to t naught. So when t is equal to 0 here, this function will completely generate 1. E power j0 is 1. So have a by t naught, and this one minus minus will give you plus a by t naught square into t naught. 1 t naught and 1 t naught will get cancelled. Only a by t naught. Whatever I have is e power minus j k 2 pi by t naught. Substitute the limit. This will give you t naught. T naught will get cancelled. I have minus e power minus j 2 pi k. And when you put 0 here, this value completely becomes e power j0. It will become minus 1. Denominator will become simply j by 2 pi k. Any doubt? Any of you? Any doubt here? Any doubt means I'll explain once again. So, what is the value of e power j 2 pi k? It is cos 2 pi k. Cos 2 pi will always give you 1. 1 minus 1 will give you 0. And sin 2 pi k will always give you 0 because sin 2 pi, 4 pi, 6 pi, all of them are 0. So this function will give you 0. So second function will become completely 0. I have only a by t naught. Now, what happens? Let us get y of k. And this function will generate infinity when k becomes 0. That's why I had to separately evaluate x of 0. So what is your x of 0? X of 0, let us go to the signal. This is your x of 0. X of 0 has a value of a. So what I will do, I'll go here. X of 0, 1 by t naught, integral from 0 to t naught x of t dt. So 1 by t naught, a minus a naught by t into t dt, integral for a period of t naught. So this will give me, after performing integration, a into t naught by 2. Okay, so this value will get cancelled. This will become t naught square, t naught square by 2. So 1 t naught will get cancelled. I have a t naught by 2. Once I do this one, I need to get the final value. So y of k is equal to a by t naught. You have the value once. But what is actually y of t? How y of t is related to x of t? Y of t is equal to derivative of x of t. So y of k is nothing but j k omega naught into x of k. So derivative in time, that is a signal, gets transformed into jk omega naught in the frequency domain that we have seen in the previous class. That is properties of Fourier series. So once you obtain this one y of k, I'll write y of k is equal to jk omega naught into x of k. So what is your x of k? X of k is equal to 1 by jk omega naught into y of k. So your x of k is equal to divide your y of k by 1 by j omega naught k. So when k is equal to 0, divide this value. So I have a t naught by 2 divided by j omega naught k. You'll get this value. And earlier cases, it is a by t naught divided by j omega naught k. So a by t naught divided by j omega naught k are written when k is not equal to 0. When k is equal to 0, a t naught by 2 divided by jk omega naught. That will solve the problem. So this is nothing but a t naught when k is, once again, once again. A T naught by 2, it is actually, I missed it, A T naught by 2, and once you take this one this side, A by 2 J 2 by K. That will give me when K is equal to, K is not equal to 0. Once again. I think I missed K T naught in the denominator. No problem. You can take this one, leave it as it is. When K equal to 0, you take this answer. When K is not equal to 0, you can take this answer. Okay. So, any doubt in this problem? Any doubt here? Shall I proceed further? Now, this is once again a rectangular pulse train is shown here. So once again, use the differentiation property to evaluate x of k. So what happens? Take x of t and find the derivative. How do you find the derivative of this one? See, derivative of this constant when 1, it is 0. That's what I indicated here. Derivative is 0. This is considered as a falling ramp. So what is the derivative of t? Derivative of t is 1. So this is a falling ramp, therefore it is minus 1 here. It is a rising ramp, therefore it is plus 1. Any of you have any doubt here? Nishant? Are you able to follow? What is the meaning of the whatever I done?
Sir?
Any doubt here?
No, sir.
Are you able to follow?
No, sir.
Okay. Now, see here, at minus t naught by 2 you have plus 1, at plus t naught by 2 you have minus 1, at 0 you have 0. Remaining things you need not have to write, only one cycle you can show, but I've shown for remaining cycle also, it is same thing. So I put 3 dots on the right hand side and left hand side to indicate this one. Okay, once I do this one, now what is the period of the signal? Let us consider total period is t. In the total period, I will take from minus t by 2 to plus t by 2. One complete cycle. You can take from 0 to t also, this half and this half, or you can take from 0 to minus t. Choice is yours, but I taken from minus t by 2 to plus t by 2. All the cases you are going to get the same answer. There is nothing wrong in choosing from 0 to t. Now, what is this value? See, this is minus 1. So I'll write minus 1 here. This is nothing but 1 at t naught by 2. So what I will write it as delta of t minus t naught by 2. That is delta of t shifted by t naught by 2. This is the function. And amplitude is minus 1. Similarly, delta of t shifted by t naught by 2, amplitude is plus 1. So it is 1, but shifting is plus because you are done in a backward manner. So delta of t is at t equal to 0, shifted backwards by t naught by 2 and shifted forward by t naught by 2. So it is plus 1 and minus 1. Okay, once I done this one, y of k is equal to 1 by t, integral from minus t by 2 to plus t by 2, y of t into e power minus jk omega naught t dt. So this is equal to 1 by t, integral from minus t by 2 to plus t by 2. So I have y of t and this value, okay, so are taken delta of t plus t naught by 2 minus delta of t minus t naught by 2 into e power minus jk omega naught t as it is. Okay, so this is just a substitution of y of t. Using the shifting property, what I have is, I'll write, because there is no need of integration because delta of t exists only at the relevant points. So I'll write e power minus jk omega naught t. This is the result where at t equal to minus t naught by 2 for the first one, minus at t equal to t naught by 2 for the second one. End out here. So don't integrate when there is a delta function. That's all. Okay. So any other function you need to integrate. Once you do this one, okay, this is e power minus jk omega naught t. Okay, where substitute t equal to minus t naught by 2. So I substituted t equal to minus t naught by 2, have this one, minus e power minus jk omega naught, substitute t equal to t naught by 2, I have this value. So what is this value? E power jx minus e power minus jx. Okay, so it is it should become plus because it is minus into minus, it is plus. So make it plus here. E power j k omega naught t naught by 2, and this is, so I'll write plus here. It is plus. Okay, so this is minus. So e power jx minus e power minus jx, that will give you 2j sine of x. So I'll written 2j by t sine of k omega naught t naught by 2. So this is your y of k. But I don't want the Fourier series coefficients of y of k. I want the Fourier series coefficients of x of k. So what I will do, I know y of t is equal to derivative of x of t. Okay, because I'm using differentiation property. Y of t is nothing but derivative of x of t. Therefore, y of k is nothing but jk omega naught into x of k. So what is your x of k? 1 by jk omega naught into y of k. So 1 by jk omega naught, what is your y of k? 2j by t sine of k omega naught t naught by 2. So j will get cancelled. I have 2 by k omega naught t into sine of k omega naught t naught by 2. So 2 k omega naught is expanded as 2 pi f naught, and here also I'm expanding omega naught by 2 pi f naught. 2 will get cancelled. Here also 2 will get cancelled. I have 1 by pi k f naught into t sine of pi k f naught into t naught. So this I will write it as sine of pi x by pi x. I will write it as sinc x k f naught into t naught. Okay, so this is the total answer. Okay, otherwise you can write at this point only, there is nothing wrong. Even if you write at this point also, there is nothing wrong. When k becomes 0 here, the denominator, it will become infinity. Therefore I have to evaluate x of 0 separately. When k becomes 0, I'll write x of 0 is equal to 1 by t integral from minus pi by 2 to plus t by 2 x of t dt. Anybody, what's the value of x of 0? Any of you? Sahana, what's the value of x of 0? Look here. What is the value of x of 0? What is the value of the signal when t equal to 0? What is the value of the signal when t equal to 0? Any of you? What will be the value of my signal when t equal to 0?
Not.
Huh? What's the value? What's the value? No. When t equal to 0, what is the value of x of t? I'm asking amplitude value. What's amplitude here? 1. That's what you substitute. See here, I'm substituting when t is equal to 0, amplitude value is 1, I'm substituting. Okay, minus t naught by 2 to plus t naught by 2. Because remaining values, it is 0. Look at the signal. Minus t naught by 2 to plus t naught by 2, it is 1. Remaining values, it is 0. Therefore, there is no need to substitute. Within the limits only, I am substituting. Hence, I am evaluating x of 0 as this one. 1 by t, 1 dt. So, t naught by 2 minus of minus t naught by 2, it will become plus t naught by t naught. So, t naught by t is my answer. Therefore, x of 0 is evaluated, and x of k for any value k is not equal to 0 is evaluated. This solves this problem. Any doubt here? Okay. We'll take one more problem. Find the complex Fourier series or x of t mod of sine of pi t. Means sine of pi t will have 0 to 1 and 1 to 2 in the opposite direction. When you take mod, all the values will become this one. Can any of you identify the signal? Yes, Sanjay? How does this signal look like? What does this signal look like?
Rectifier.
It is like a full wave rectifier signal. That's all. Okay. Look here. Mod is given means you should not draw negative values. All the signal you have to draw is a positive values only. Okay. So I'll write sine of pi t. What's the period of signal? It is 1, because for every 1 interval signal is repeating. Therefore, I'll write omega naught equal to 2 pi by t naught. When t naught is equal to 1, I'll write it is equal to 2 pi. So x of t is equal to sine of pi t for the period t equal to 0 to 1. So what is my x of k? X of k is equal to 1 by t naught, integral for a period of t naught, x of t into e power minus jk omega naught t. When omega naught is 2 pi, I'm substituting e power minus jk 2 pi into t sine of pi t. Between the limits 0 to 1. One cycle only, and what is t naught is 1. So what I will do, I'll take the direct formula. Otherwise also you can integrate. Given the formula in the previous classes, I think I'll show you the formula which I given in the previous class. I'll show you the formula also where I given you. I think I've given you formula here. See here, this is the formula I'm using. See here, this is the formula. E power ax sin of bx plus c dx is equal to e power ax by a square plus b square, a sin bx plus c minus b cos bx plus c. So this formula is used here to simplify. So e power minus jk 2 pi t is as it is. So a square. So a square is minus jk 2 pi and b square is pi square. This is a and this is b. So a sin pi t. So a is this much minus jk 2 pi into sin of pi t minus b. B is this one, that is pi into cos of 2k pi t. So when k is constant, when k is equal to, t is equal to 1, so you have only cos pi t. So sin of pi t is always 0, therefore there is no need to worry. And this quantity e power j 2 pi k, it is always 1. Cos of 2 pi k plus sin of 2 pi k. Sin of 2 pi k is 0, cos of 2 pi k is 1. So I have only 1 divided by minus j square. So minus j square is minus 1, k square, 4 pi square plus pi square. Here minus pi, when cos pi is minus 1, minus cos 0 is minus 1. So total is 2, and 1 pi in the denominator will get cancelled. What I have left with only pi into minus 4k square plus 1. This solves your problem. Okay. So any doubt here? Okay. This is your x of k. It's a very simple problem. Okay. We'll get 6 marks for the problem, but solve the problem carefully. First evaluate the function and try to, if you remember only this formula, you'll be able to solve any problem. Identify the period, and once you identify the period, substitute within the limits and integrate. If you are not able to remember this formula at integration, so sin of pi t should be written as e power j pi t minus e power minus j 2 pi t divided by 2j, and then make 2 parts and then integrate and then solve the problem. Choice is yours. There is no rule that you should solve the problem by this means. I have taken the ready-made formula, but if you don't know the ready-made formula, you can solve by the other way also. Okay, there is nothing wrong. If you can integrate in the calculator, that also is fine, but we prefer showing the steps, because for the steps only you are going to get the marks. Okay.